And good morning, everybody. Here are some additional examples for simplifying trigonometric expressions, and we're going to be using some basic trig identities that we talked about yesterday. And just as a refresher, here's the identities that we're going to be using. So these are all formulas that you want to start kind of memorizing for the course. So you have your reciprocal identities, your tangent and cotangent in terms of sines and cosines, and then you have your three Pythagorean identities. And let's just go ahead and go through some examples. These are going to be examples that line up with the first 10 questions in your textbook if you're one of my students, section 3.1, questions 1 through 10. And they're going to be techniques or strategies that we're going to be using kind of for the rest of chapter 3 to help simplify trigonometric expressions. So let's go ahead and just walk through a few of these different techniques. And here's the first one. So we have cosecant divided by cotangent. One of the things that usually helps if you can't think of a place to start is to just switch everything to sines and cosines. So switch it over to kind of the two most popular trig functions. So we know cosecant is the reciprocal with sine, so we're going to call that 1 over sine. And we know that cotangent is cosine over sine. And again, this is kind of new to us. So where are these identities coming from? These are coming from our list here. That cosecant is just the same thing as 1 over sine, and cotangent is the same thing as cosine over sine. This leaves us with a fraction divided by a fraction, so you want to multiply by the reciprocal. So the 1 over sine is going to be multiplied by the reciprocal of the bottom, which is sine over cosine. And now we have common factors, top and bottom. Sine divided by itself, sine, those are going to cancel. And you're left with 1 over cosine. And according to our identities, cosine is the reciprocal with secant, so 1 over cosine would just be identical to secant. So simplified, taking the original expression, we can simplify it to secant. And here's another example. We'll do a similar technique. We'll switch everything to sines and cosines first. So tangent we know is sine over cosine. Secant is the reciprocal with cosine, so we'll call that 1 over cosine. And you have a fraction divided by a fraction, so it's going to be the same as multiplying by the reciprocal. So sine x over cosine is up top in the numerator, and then so that's your numerator, and then we're going to multiply by the reciprocal of the denominator, so that's going to be cosine over 1. So we're going to flip this, and that's going to be cosine over 1, and then your cosines cancel. So you are left with sine of x. So there's your simplified form. So tangent over secant, tangent of x divided by secant of x, can be simplified to sine of x. And here's a third example. Again, we'll switch to sines and cosines first. If you ever get stuck trying to work with trig identities, option 1 is always to switch it to sines and cosines and see what it looks like. So cosine up top, that's already in terms of sines or cosines, but the bottom one, the secant, we could call that 1 over cosine. So we'll say we have cosine up top, divided by the secant expression is going to be turned to 1 over cosine, plus, and then the second fraction, we have sine of x, And cosecant is the reciprocal with sine, so that's going to be 1 over sine is the same thing as the cosecant. And now we have the top fraction. We have cosine divided by 1 over cosine, so we're going to multiply by the reciprocal. So that's going to be cosine up top multiplied by the reciprocal of the bottom, which is essentially cosine over 1. Plus, and then we can do the same thing on this second fraction. We have sine up top multiplied by the reciprocal of the bottom fraction, which is sine over 1. So we ultimately end up with cosine times cosine up top in the numerator, all over 1, so cosine squared. So this is going to become cosine squared plus sine times sine up top, so sine squared. And one of our identities, the Pythagorean identity, says that sine squared plus cosine squared is always equal to 1. So that's going to be our final answer. So this original expression, if you simplify it, is simply going to be a value of 1 all the time. And here's another example. This one doesn't quite follow the strategy of just switch everything to sines and cosines. It's starting to kind of recognize some of the other options. So the first one we have is 1 over cosine squared, and we know cosine is the reciprocal with secant. So 1 over cosine is the same thing as secant. So 1 over cosine squared would be the same thing as secant squared. And again, the identity that we're using on this one so we're using this fact right here, that cosine is the reciprocal with secant, so 1 over cosine must be the same thing as secant, or 1 over cosine squared is the same thing as secant squared. And then cotangent is the reciprocal with tangent, so 1 over cotangent would be the same thing as tangent squared. And here's where it gets a little bit different. We need to think about our Pythagorean identities and start to recognize when we kind of have the parts and pieces of the Pythagorean identities. So one of the Pythagorean identities is that 1 plus tangent squared is always identical to secant squared. So if we rearrange this known fact, or this known formula, can we rearrange it to kind of express what we have over here on the left? Basically, if you subtract tangent from both sides, tangent squared, then you're going to be left with 1 on the left is equal to secant squared minus tangent squared. So essentially, by way of one of our Pythagorean identities, this is the original form, or one of the 3 original forms, we can rearrange this known formula to essentially tell us that secant squared minus tangent squared must be equal to a value of 1. And what we have in our work is exactly what we have over here. Secant squared minus tangent squared is always identical to 1. So this can just be called a value of 1. So this original expression can be simplified to a value of 1. And here's another example when we're not going to necessarily just switch everything to sines and cosines to start, but we can use some of our Pythagorean identities. So if we have a binomial times a binomial, we can multiply these together. So you can distribute your 1. So 1 times 1 should get you 1. 1 times cosine would be positive cosine. And and then distribute your negative cosine. Negative cosine times 1 is negative cosine. And distribute your negative cosine to the next term. Negative cosine times positive cosine. A negative times a positive should be a negative. And cosine times cosine should be cosine squared. So for these, remember the trig expressions are basically variables, since we don't know what cosine is, so you can treat it like a variable. So it's really no different than if we had, for example, 1 minus x multiplied by 1 plus x. The x is the unknown. Here it's just the cosine. The cosine is kind of acting as the variable. So you can multiply them together just like we would normal algebraic expressions. So 1 times 1 should get you 1. 1 times x is positive x. Negative x times 1 is negative x. X times x is x squared, but you have a negative times a positive, so that's going to be negative x squared. So all the same algebraic properties that you would use for a variable x, you can use those with your trig function since they are unknown. And looking back to the trig expression, we have 1 plus cosine minus cosine, so positive cosine minus cosine, that's going to cancel and become 0. So you're left with 1 minus cosine squared. And if we think of our Pythagorean identities, sine squared plus cosine squared is always 1. This has the components of a Pythagorean identity. It has the 1, and it has the cosine squared. It's just not quite in the same order as the original Pythagorean identity, but we could rearrange the order. So if we took the cosine squared and subtracted cosine squared from the left, then you're going to be left with sine squared. And whatever you do to one side, do it to the other side. So we're going to subtract cosine squared from this side. So on the right-hand side of the equation, you're going to be left with 1 minus cosine squared. And 1 minus cosine squared is identical to sine squared. So where we see 1 minus cosine squared in our work, we can replace that with sine squared, so a basic substitution step. So 1 minus cosine squared is just sine squared. So that would be your simplified form. So the original statement could be simplified down to just sine squared. And here's another example where we can multiply the two binomials together. So we have cosecant times cosecant, so it's going to be cosecant squared. And then cosecant times the 1 is going to be cosecant. And then distribute your negative 1. So negative 1 times cosecant is negative cosecant. And negative 1 times positive 1 is negative 1. And in the middle, your cosecants will cancel. Positive cosecant minus cosecant is 0 cosecant, which means you're left with cosecant squared minus 1. And this has, again, all the parts and pieces, or most of the parts and pieces of one of the Pythagorean identities. So we know that 1 plus tangent squared is secant squared. And we also know that 1 plus cotangent squared is cosecant squared. So if we subtract the 1 over to this side, so subtract 1 from the left, you're going to be left with cotangent squared. And on the right, you're going to be left with cosecant squared minus 1. So cosecant squared minus 1 is identical to cotangent squared, so we can replace this with a cotangent squared. So the original statement will simplify to just cotangent squared. And here's another one very similar to the other 2 or 3. The only difference is before multiplying this all together, you're going to want to simplify a little bit first. And what you want to pick up on, or what you want to notice, is the cotangent right here. Cotangent, one of its identities is that cotangent is cosine over sine. So if we switch our cotangent, so we start with sine of beta, switch your cotangent to cosine over sine. Notice that your sines are going to cancel top and bottom, and then you still have the plus 1. And then cosine beta minus 1 is the other factor. So right here, before we start multiplying these 2 binomials together, you can actually simplify the first binomial. So it's going to be cosine beta plus 1 multiplied by cosine beta minus 1. And now that the first one is simplified and we no longer have the cotangent involved, now we can go ahead and distribute and multiply. So cosine times cosine should get you cosine squared. Cosine times the negative 1 should get you negative cosine. 1 times cosine should get you positive cosine. And 1 times the negative 1 will get you negative 1. Your 2 middle terms are opposites, so those go to 0 and cancel. And you're left with cosine squared beta minus 1. And if we look at our Pythagorean identity, sine squared plus cosine squared is always 1. How could we get this original identity to kind of match up with what we have? We have a negative 1, so we're going to have to bring our 1 to this side, and then we can subtract our sine squared to the other side. So that's going to get us cosine squared minus 1 on the left is equal to, and then when we subtract sine squared, it's going to come over as a negative sine squared. So cosine squared minus 1 is identical to negative sine squared. And beta. So there's your simplified form for that. And here's another example. For this one, the strategy would be to take what we have right here at the beginning and see if we can simplify this first. We'll switch everything to sines and cosines. So we're going to have 1 plus the sine alpha. We'll write that as just sine over 1. Times cotangent alpha. We know cotangent is cosine over sine. And then secant is reciprocal with cosine, so it's going to be 1 over cosine. And then it's still all over secant. And notice what happens on these 3 fractions. Sine divided by sine, that's going to cancel. Cosine divided by cosine, that's going to cancel. So you're left with basically 1 times 1 times 1. So 1 times 1 times 1 is 1. So it's going to be 1 plus all of this is just going to simplify to another 1 all over secant. And 1 plus 1 up top is going to be 2. that's not a bad answer. You could take it one step further. Secant we know is the reciprocal with cosine, so 2 over 1 over cosine. And then if you multiply by the reciprocal, it's going to be 2 over 1 basically multiplied by the reciprocal of cosine over 1. So it was 1 over cosine down bottom, so the reciprocal is cosine over 1. And 2 times cosine over 1 is just 2 cosine of alpha. So that would be your simplified form for the original expression. And here's one more example. I think I said 10 at the beginning, but there's actually only 9. So here's the last one. So similar to the other one, we want to simplify first. So if we look at the cotangent, we know cotangent is cosine over sine. That's going to put us a sine down bottom, which is going to cancel with this sine, which is up top. So let's rewrite first. So we'll say this is going to be sine of alpha. The cotangent, we're going to switch that to cosine of alpha over sine of alpha. And this is sine over 1 plus the 1. And let's make that parenthesis a little bit big. So our first statement, we switched the cotangent to cosine over sine, multiplied by cosine alpha minus 1, all over sine squared. And up here where we did our rewrite, sine divided by itself, that's going to cancel, so you're left with cosine alpha plus 1. So we'll call this cosine alpha plus 1 multiplied by cosine alpha minus 1 all over sine squared. And then we can multiply the two binomials together. So we can do cosine times cosine. That's going to get us cosine squared. And then we can do cosine times the negative 1. That's going to get us negative cosine. And then distribute your 1. 1 times cosine, that's going to get you positive cosine. And then 1 times the negative 1, that's going to get you negative 1. All over sine squared. And your two middle terms will cancel. So up top you're left with cosine squared minus 1. All over sine squared down bottom. And cosine squared, need an angle in there, angle statement. So up top, cosine of alpha squared minus 1 all over sine of alpha squared. So the numerator has the parts and pieces of the Pythagorean identity. So we know Pythagorean identity, sine squared plus cosine squared is 1. So if we subtract the 1 to this side and then bring the sine to this side, it's going to read cosine squared minus 1. Must equal negative sine squared. So our numerator, we can rewrite that as negative sine squared all over sine squared. And anything divided by itself is 1, so sine squared divided by sine squared is 1, but we have the negative, so we're going to be left with negative 1 for our final answer. So there's your simplified form. So this original expression can be simplified all the way down to a value of -1. And those are 9 examples that go along with the first 10 problems in the problem set, section 3.1 out of your Trig books. And you want to start really focusing on those different strategies. Those are going to be strategies that we're going to be looking for most of the problems that we keep doing in the chapter 3.